Hello everyone, I hope you enjoyed our last lesson. Today I want to talk about these four topics: absolute values, distributive property, greatest common factors, and least common multiples. If you are ready, let's get started.
Absolute values. An absolute value of a number basically means the distance of that number from 0 on the number line. Since the distance is always a positive value, therefore the absolute value cannot be negative. The absolute value of x is displayed by this symbol. For example, in here, the absolute value of -7 is 7. If we want to give an example for absolute values in the real world, we can refer these examples. Sam is sitting 3 chairs to my left in my perspective, and Ava is sitting 3 chairs to my right in my perspective. Or on the vertical number line, in our building, Rose's apartment is 1 level higher than mine, and Jack's apartment is 1 level lower than mine. Now, let me tell you a few facts. First things first, the absolute value of 0 is 0. Second, we know that each positive number is greater than each negative number. For example, 3 is greater than -10, but this doesn't mean that the absolute value of that negative number is smaller than the absolute value of that positive number. As you can see, in the previous example, the absolute value of -10, which is 10, is greater than 3. The next thing I want to talk about is the distributive property. First, I must remind you that when we write A parentheses B, we mean A times B. Now, please pay attention to this multiplication example. If we want to multiply A by the total of 2 numbers called B and C, we can actually multiply A by B first and then multiply A by C separately and then add the results together. This is the concept of distributive property. For example, we can write 5 parentheses 3 plus 6 right like 5 times 3 plus 5 times 6. You can calculate both sides of the equation and see that the result is the same, which is 45. One of the application examples of property distribution is calculating the perimeter of a rectangle. The next concept is the greatest common factor, which we call GCF for short. Consider this example. We have 16 and 4. First, we list the factors of each of these numbers. 16 can be a product of 1 times 16, 2 times 8, and 4 times 4. 4 can be a product of 1 times 4 and 2 times 2. Common factors in both lists are 1, 2, and 4, and of all of them, 4 is the greatest. As you can see, if we want to add 16 to 4, we can use GCF and write it as a distributive property. So far, we have seen the steps to find GCF of 2 or more numbers. 1. Find the factors of each number. 2. Identify the common factors in all of them. And finally, 3. Identify the greatest common factor that they have. In the next example, we want to find the GCF of 3 numbers, 12, 24, and 6. By listing the factors of each of these numbers, you can see that 6 is the greatest common factor that they have in common. There is another concept called least common multiple, which we show with LCM for short. To list the multiples of a number, just multiply that number by whole numbers except 0. For example, multiples of 3 are 3 times 1, 3 times 2, 3 times 3, and so on. As you can see in this example, to find the LCM of 2 and 5, I have written a list of multiples for each, which 10 is the smallest multiple in both lists. Well, let me tell you something. As soon as we see a common multiple, we know that it's the least common multiple, and we stop the process of finding the least common multiple. The steps to find the LCM of 2 or more numbers are 1. Multiply each number by whole numbers except 0. 2. Identify the common multiple in all of them. And 3. Identify the least common multiple that they have in common. In this example, you can see these steps in play to find the LCM of 3, 6, and 8 in here, which is 24. Can you guess what song this was? Okay, great. Let me get to my final question. Imagine A and B are variable numbers. Now, between the GCF and LCM of A and B, which is bigger and which is smaller? Thanks for watching and see you next time.